Okay, next we're talking about variation, and that again was on page 369. I'd appreciate if you would read that over. But variation is basically the description of how widely the data values are spread out about the center of the distribution. So in this, how widely it's spread about the x values here. On a graph here, this is the x values and here's the y. So it's kind of like how far spread out is that in the variation. So you can see this is a low variation here. This one here may be considered moderate, really vague in that description. I dislike these questions that they ask about it. And this one here would be a higher variation because the data values are stretched out on the wider part of a x value line. Okay, so they're talking about this in number 7, and it says consider the distribution of the annual rainfall in 99 cities selected randomly throughout the United States. Complete parts A through D below. How many peaks would you expect for the distribution? Alright, so it's consider the distribution of the annual rainfall in 99 cities selected randomly throughout the United States. And what do you think? So it's an average of rainfall for all 99 cities. So nothing else is said about it. So it's the answer for this is D. There would probably be one peak because there are no obvious reasons why the values of the annual rainfall would form different groups. Right, so rain is rain, so what's the average annual rainfall for the 99 cities? So that makes sense with that respect. But then it says make a sketch of the distribution. Choose the correct answer below. And I didn't write that here, but I could use this one. Then they have some other ones here. You've got it there. Well, I won't elaborate on it, but the answer for 7B is D, where they have a graph here and the tail is cut off, meaning it looks like, I'll erase this one altogether, and it's the one that looks like this, where it starts here and virtually goes up and then back down, then it's got more of a tail on the right side. This one's cut off here. So what does that mean? What does that mean here? So the annual rainfall is in this respect here that there's values here starting out immediately right away for the rainfall that's coming down. It's like nowhere is there a place that has zero rain. However, California has a drought, so a little bit vague on that, but that's what they're depicting here with that. There's always rain somewhere, everywhere. So you're not going to have a zero amount of rain. And that's why this looks that way. C, what shape would you expect for the distribution? The distribution would probably be right skewed because there is a clear minimum amount of rainfall, but no obvious maximum amount of rainfall. And that's what this is here. This one is indeed right skewed. Okay. D, what variation would you expect in the distribution? And this is part D of 7. What would the distribution be? Would it be large? You would have rainfall on both ends, but the majority of it being in the middle. So you would have it, and it would probably be wide. Consider California with the drought. It does have rain, but little. And then same thing over on the other side as well, where it has these X values take up how much rain it is, but it's not as much on the average. Okay, shall I go on to number 8? Let's see if I can do that without stopping. Consider the distribution of the prices of 15-pound bags of 23 different brands of dog food. Complete parts A through D below. All right, and here's the same type of thing with this. How many peaks would you expect for the distribution? And this is for number 8. And again, consider the distribution of the prices of 15-pound bags of 23 different brands of dog food. How many peaks would you expect from this distribution? All these prices. Well, it would be B. There would probably be 1 peak because there's no obvious reasons why the prices of dog food would form different groups. Okay, that's a little bit more concrete than this first one about the rainfall, in my opinion. Part B, make a sketch of the distribution. What do you think it would look like? Choose the correct answer below. And that would be C, where it does have the tails on it. You could finish this tail off here. Excuse my drawing here. Probably something like this one here. This is C here. You know, something that looks like that. There's 2 tails on it. What shape would you expect for the distribution? And the answer to that would be C. The distribution would probably be symmetric because there's no obvious factors to indicate that there would be more high or low price items. Okay, and that would be C. Part D, what variation would you expect in the distribution? I think this is the one that says, oh, I won't say it until I see it, and that is B. The variation would probably be moderate. Yes, probably be moderate because there are no obvious reasons to expect an especially large or small amount of variation. So again, you know, on some of these problems where there's it's ambiguous, I'll call it, or ambivalent, to say run these with the similar exercise. Do 2 or 3 of them so you can see the pattern, what they're taking, where they're coming from. I think you understand the problem a little bit more when you do that. Next, we're talking about histograms. The histogram to the right shows the times between eruptions of a geyser for a sample of 300 eruptions, which means 299 times between eruptions, over the histogram. Draw a small curve that captures its general features. Then classify the distribution according to its number of peaks and its symmetry or skewness. So you can see that is symmetric already. You agree. So if you drew, what did it say to do then? Over the histogram, draw a smooth curve that captures its general features. So you can see it's low and then it's going to go up, over, back, down. So this is what? Choose the correct answer below. 1 peak, symmetric, low variation. And 3 peaked, symmetric, wide variation. Well, you know it's not B. C, 1 peak, right skewed, moderate variation. This isn't skewed. It is symmetric. And the last one, 2 peaks. No, there's not 2 peaks, there's 1. So the answer to that would be 1 peak, symmetric, low variation. All right, that's for number 9. Number 10. Suppose you study family income in a random sample of 200 families. Your results can be summarized as the mean family income was $50,000, the median family income was $27,000, the highest and lowest incomes were $258,000 and $2,600 respectively, the highest and the lowest incomes. Draw a rough sketch of the income distribution with clearly labeled axes. Choose the correct answer below. All right, which graph depicts those income levels is what they're after. Which graph depicts those income levels? And I do believe it is, which one do you think? I think it's A. The income is on the bottom for the x-axis. Yeah, they all are. So looks like it's going to be A. Because most people make, you know, you can see that it's right skewed. Let me get my number out here. So if I draw this, let me get rid of this here. kind of exaggerate A. So here's the graph, and this is saying this is 2600, and it's here, and then the graph goes up and then down this way, and the tail is over here at 258,000, right? So that means few people make 258,000. Most of the people make the average, which is here, and then some people are low on the income level with 2,600, probably collecting Social Security. Okay, so whatever the reason is, they're low on the poll here, but this is the average, which may be, I don't know, what is the average income? 40,000, 35? I'm not sure. But then you can see some people make 50,000, 60,000, 70,000, all the way up to 258. Okay, where that's on that incline there. What do you think this is? Is this right skewed, left skewed, or symmetric? Okay, this graph here, as I'm drawing or looking at A, this is going to be right skewed. Fewer people make higher salaries of money than the people that make the average amount. How many families in the sample earn less than $27,000? Explain how you know that. Okay, and the answer to that is you have 200 families in the sample, and it goes on to say that the median was 27,000. Okay, so here's our line, or here's our data values, right, of 200 samples, and the median, the one in the middle, is 27,000. Right? So how many does that, what does that mean? That means 100 families. Right? Because you got the number in the middle, 200 families is an even number, so you're taking the two values here in this case for that reach to 27,000. So if you have two values here, that leaves what? How many families in the sample earn less than 27,000? So if these are the two in the middle, it would be earn less than 27,000 would be 50 families, because the mean is the average value of income. Oh, I'm sorry, not 50, 100, because of the 200 altogether. And the mean is in the middle of these two here. Does that make sense? Am I making sense? So if this is 200 altogether, and these are the two middle numbers of that data set, it's the number in the middle because it's an even number of values, even number of people. So it's the middle number. So how many people are to the left and how many people are to the right? In other words, how many people make less than 27,000? How many people make more than 27,000? And because this is in the middle, you've got 100 going to the left, and to the right you have 100. And that's your sample of 200 families. Okay, number C, letter C, based on the given data, can you determine how many families earn more than $50,000? Why or why not? And that is, we cannot determine that because we don't know the distribution. So that would be A. We know because the number of families that earn more than 50,000 depends on the distribution, and we don't know that. We do the median. We know how many families there are, so we can answer that one, but not part C. Okay, we've got number 11, getting more into the calculator work with what are the quartiles of a distribution and how do we find them. All right, let me get the book out and I'll be right back.